Hi, topic for this session is matrices. It's somewhat similar to a 2D array that we did in the previous sessions. It's a 2D array that has a number of rows and columns. That is what makes a matrix. Suppose we have an array of 5 into 4. 5 is the number of rows and 4 is the number of columns. Right. So this is how it will look like. Okay. Right. So let's see how. First let's start with the matrices addition, how it happens. Suppose we have two matrices given on the screen. We have elements 5 1 2 4 3, sorry, 2 2 3 4, 10 6 7 8 9 15 11 12 13 and 14, 20 16 17 18 and 19, another array with different set of elements. The prerequisite of addition of a matrix, as we know, is the number of rows and columns of the first matrix should be equal to the number of rows and columns of the second matrix. That is a prerequisite requirement for an addition of matrices, or prerequisite. So it will eventually add each element. 5 will be added to 1, this 5 will be added to 1, 1 will be added to 2, 2 will be added to 3, 3 will be added to 4, be added to 5. This is how the addition. One element is added to one of the corresponding elements at the same number row and column element, and will give this final output. Right, this is how addition of matrix takes place. Let's see with the help of an code. Suppose we have declared two elements, two matrices, first and second, and third is for storing the summation of the addition value, final matrix that we get after addition. Took the number of rows and columns that we want for each of the two matrices, or all three of the three matrices, right? Then we took the input of all the elements of first matrix, that is actually a 2D array. Then for the second 2D array, that is matrix, and then we perform the addition of each element of the first matrix to corresponding each element of the second matrix, and store in the third corresponding element of the sum matrix, which will store the actual result. Right. So it's a simple addition, is very simple. We simply add cth row dth column element of the first matrix to the cth row dth element or dth column of the second matrix, and store it in the cth row and dth column of the final matrix, which is storing the result. Right, and then we can print it here also, or we can make another double loop scenario for C and D, and then print it once the addition is done for all the elements. Whether we can do that, or we can print it as and when the addition occurs, because not going to make change with the next iteration, right? So we can print it here as well. Okay, and the second scenario, we are doing the transpose of matrix. Transpose of matrix, you also know the all the row elements come to the column elements. 1 2 3 will, which is the first row, becomes the first column of the resultant matrix. Right, for this we have a small code. Right, we have main, in which we have two matrices. First is the one whose transpose we are supposed to find, and second is to store the value of transpose matrix. Right, we go from the we took in the number of elements we want in an array or 2D array or matrix. This should not actually be greater than 10, right? Take care about it. And then we took in or scan or take the value of each element of the initial matrix from the user. Then we transpose it by a simple swapping of I and j. The final matrix transpose jth row ith column will be the value of ith row and jth column of the initial matrix. This is the main crux of a transpose program or the logic. Right, finally we print the transpose of the matrix. Okay, so that is the couple of examples on how to handle the matrix. That's all. Thank you.